Hi everyone. This lesson is a very important lesson to remember and understand because I can promise you, you will be using it next year in geometry. A lot of these radical lessons are extremely important, so I really encourage you to take the notes along with this video and to write down these three examples. What is something that is very important in each of these is there's a square root in the denominator. Now I could have had square roots in the numerator as well, but I'm purposely focusing on the denominator. We do not want to have radicals in the denominator. That is not allowed in your final answer. So there is a specific rule to undo that, and it's called rationalizing the denominator. And again, this is from your textbook. If you have your textbook, it is page 721 in this section here. They don't really include very many examples, so that's why I tried to include more of my own. Hold on, let me get rid of this. So what we have to do to rationalize the denominator is you multiply both the numerator and the denominator by the square root that is in the denominator. So I see in the first example there's a square root of 7 in the denominator. So I'm going to write another fraction directly next to it, and I'm multiplying the numerator of 8 by radical 7 and the denominator of radical 7 by radical 7. And if you remember your multiplication rules, 8 times radical 7, since they're both not in the radical, we don't multiply them together. We just have 8 root 7. Then in the bottom, when you multiply the same number by itself and they are both in the radical, you can either say 7 times 7 is equal to the square root of 49, or you can just cancel out the radicals. So radical 7 times radical 7 is equal to just 7. And that is your final answer. You cannot simplify radical 7 over 7. It doesn't work that way. You can only simplify numbers that are outside of the radicals themselves. Going on to the next example, to prove that point, you cannot simplify 6 over 3 and get 2. 3 is in a radical, so you cannot simplify that way. So our only choice is to rationalize the denominator like we did in the top. So you multiply both the numerator and denominator by the radical that is already in the denominator. So you're multiplying both by radical 3. So 6 times radical 3 is just 6 radical 3. Again, you cannot multiply a whole number by a radical and get 18. Cannot do that. And in the bottom, radical 3 times radical 3 is just 3. Now from here you can assess, can I simplify the whole numbers? And I hope you're saying yes, you can. 6 over 3 simplifies to 2, and radical 3 remains as is. Do not simplify radical 3 and 3 together. And so 2 radical 3 is your final answer. In the last one, we have 9 over radical a. So you can still do the same exact work with letters as you did with the numbers. You multiply both by the radical in the denominator, so it's square root of a, square root of a. So 9 times radical a is just 9a. And the radical a times radical a is just a, and it's okay to have the variable in the denominator, and that is your final answer. Now the next few examples are also very important because I'm going to show you what happens when the bottom square root isn't actually simplified. So I'm going to erase these. I'll leave up this one in the corner for now. Let's say I gave you the example. Let me think of a good number. Let's say I chose 4 over radical 8. I could go ahead and just multiply both by radical 8, or you can simplify the radical in the denominator first. So let's show both ways. If I just wanted to multiply the bottom by radical 8, or both by radical 8, I would have 4, oops, I'm sorry, let me not skip ahead. I'd be multiplying both numerator and denominator by radical 8, radical 8, and then I notice I'm left with 4 root 8 over 8. Now there's two things you need to notice. One is I can simplify 4/8, and 2, I also need to simplify this radical of the square root of 8. So you can go right ahead and say 4 over 8 just becomes 1 over 2, which is 1 root 8 over 2. And yes, you can get rid of this 1 if you want to. This 1 doesn't change the answer at all with or without it there. And then you have to go ahead and simplify the square root of 8. So I'm hoping you're starting to pick up on how to do this quickly, because the square root of 8 is 4 and 2. 4 is a perfect square. So in the numerator, I have 2 root 2. And again, the more you get used to simplifying square roots, I now know what the square root of 8 is. I always know it's 2 root 2. Now I have 2 root 2 over 2. And then I go right ahead and simplify 2 over 2, cancels each other out, and I'm just left with the square root of 2. Now, if you weren't sure what to do, or you just wanted to go ahead and simplify the square root of 8, you're allowed to do that. So I'm going to erase this green and show you what happens. What if I decided to simplify the square root of 8 first? Now, I already told you it's 2 root 2, so I'm not going to go back into how am I getting that. And I have 4 over 2 root 2. And then I can see I can simplify 4 over 2 is just 2. So I'm left with the 2 in the numerator and a root 2 in the denominator. And now we still have to rationalize. So I still have to get rid of that root 2. So I multiply both numerator and denominator by root 2. 2 times root 2 is just 2 root 2. Root 2 times root 2 is 2. And notice we're right back where we were in the last problem. The 2's cancel each other out, and you're just left with radical 2. Many of your homework questions will probably have you simplifying at some point, but if they don't, you can just go right ahead and multiply by the radical in the denominator. Please take these notes down or pause the videos and even reference Khan Academy. I think it's a great resource to use.